An introduction to moments. Here we look at some simple real-life examples to understand what moments are. So with this spanner we can rotate this bolt clockwise to tighten it or anti-clockwise to loosen it. So to loosen this bolt we need to turn this anti-clockwise. So a force is applied in this direction at a certain distance from this point here, called the pivot point. This is the point around which motion will happen. The pivot point itself doesn't move location, it stays there. Everything rotates around it. To tighten this bolt, a force is applied so that a clockwise rotation occurs and tightens the bolt. So here we have a force applied in this direction at a certain distance from the pivot point, and the force and this line here for the distance, they are perpendicular to each other. Example 3, we apply a 20 Newton force at this point on the spanner at a distance of 0.3 meters from the pivot point, and the force and this red line for the distance are perpendicular to each other, and that creates a clockwise rotation, and we can calculate the strength of that rotation, which is called the moment, using this simple formula: force, or the magnitude of the force, times the perpendicular distance. So we have a 20 Newton force and the distance in meters is 0.3, multiply, we get 6 Newton meters. Newtons from the force, meters from the distance. We need to give the direction of rotation, so that's the magnitude of the moment and its direction is clockwise. So this turning effect due to the force is called the moment, and the strength of the moment depends on the force and the distance. In this example, this 30 Newton force will cause the spanner to move in an anti-clockwise manner, like so. So again we can calculate the strength of that rotation produced by the force by calculating the moment. 30 newtons times the perpendicular distance, and there's a right angle here between them. It's a simple example. This time it's anti-clockwise. Example 5, we have a door handle and the force is perpendicular to the arrow representing distance. Again we have a rotation clockwise this time, so we have 5 newtons times 0.15 meters, giving us a moment of 0.75 Newton meters clockwise. So I have a dog with mass 10 kilograms, and on the opposite side of the seesaw I'm going to place a cat. Now I want the seesaw to completely balance, so this will be a problem that can be solved using moments. So I need to work out the distance. I need to place the cat from the pivot to make the seesaw balance, to make the clockwise and anti-clockwise moments balance so they are equal to each other. So I've moved the cat along. It's now the same distance from the pivot as the dog is, yet the seesaw is still not balanced. So I need to move the cat even further out, and further out again and again, and now the seesaw will balance, because if we calculate moments, so the weight of the dog will be its mass times g, so 10g its weight times the perpendicular distance from the pivot times 1, and for the cat it's 5 kilograms times g, so that's the weight times the perpendicular distance, 2. So 10g Newton meters, 10g Newton meters, so these values are the same, and the moments are in opposite directions, anti-clockwise for the dog, because the dog wants the seesaw to come down. That's going to be anti-clockwise, and the cat wants the seesaw to go down on this side, which will be clockwise. And these are equal in size but opposite in direction, so we have balanced moments, so the seesaw balances. So in this problem there is also a normal reaction here at the pivot, but the normal reaction, it's a force, its distance from the pivot is 0, so any moment produced here will be 0.